Hello, this is Mr. Collier, and today we're doing some calculus or differential calculus review. Firstly, we need to remember our exponent laws because we often need to rewrite the exponents before we do find the derivative. So recall if you have x to the power of negative n, it equals 1 over x to the power of n, so we use that rule a lot. This is going to be 5x to the negative 3. You would rewrite it like this before you do the derivative. This actually is ready for the derivative, so you don't usually want to change it, or sometimes you do, but it's just equal to that. This is x to the power negative 5, 3 over x to the power 7. The 3 doesn't have an exponent, 3 stays in the numerator. Okay, we'll also be simplifying some exponents today. So when we're multiplying, we add the exponents. So that's going to be x to the power 7. When we divide, we subtract. When we have an exponent of an exponent, you multiply. This is division, again, just like over here. So you subtract, you get x to the power negative 1, or 1 over x. And actually this one's the same answer as x to the power negative 1. It's actually the same thing, just rewritten differently. Okay, let's go and do some derivatives. Let's check this one out. So we write the derivative is dy dx is, and we can take the exponent and multiply it by whatever's in front. Then the exponent is reduced by 1, and we keep doing that procedure. This is negative 6x, and this is like x to the power 1, so it becomes 8x to the power 0, and x to the power 0 is just 1. Okay, now this represents like a cubic, so it probably looks something like this. And at the point 2, 10, when you find the derivative, you're basically finding the slope at that point, but it only depends on the x value, as you see. So we're going to sub in 2, and the 12 is kind of irrelevant in this case. So dy dx equals 3 times 2 squared minus 6 times 2 plus 8. That is 12 minus 12 plus 8, so it's just 8. So the slope there is 8. Yeah, many of these are very similar. Let's take a look at this one here. This one we need to rewrite. Well, basically when x is in the denominator, we need to rewrite it before we find the derivative. So that's x to the power negative 2. And now we can find the derivative. So this is when you write dy dx, because now we're actually finding the derivative. Negative 2 comes down front. The exponent gets reduced by 1. And when you get something like 3x, it just becomes 3. And that is negative 2 over x cubed minus 3. So then we sub in the x value only. And actually that's just 1. So you're going to have dy dx equals negative 2 minus 3 is negative 5. Okay, let's take a look at number 5 here. Yeah, we got x in the denominator. That means we can divide everything here by x. Okay, so we're going to divide every term by x, and you get y equals 2x, and then x divided by x is 1. And that's 3 divided by x, which is 3 to the power of x minus 1. Then we find the derivative. That's 2, and constants become 0. So that just disappears, and we got minus 3x to the power negative 2, which is 2 minus 3 over x squared. Now we sub in 2, just the x value, and we get 2 minus 3 over 2 squared, which is 2 minus a quarter. It's basically 1.25. You can write it as a decimal, 1.25. Okay, next let's do number 3 here. Or actually number 2. Let's do number 2. Determine the gradient of the functions. That's the derivative. So f of x equals 2x to the power negative 1. And then this notation, we write an apostrophe for the derivative. Okay, and this is going to be negative 1 times 2, negative 2, x to negative 2, or negative 2 over x squared. Okay, so now we substitute in x equals 1, and that just becomes -2. And you just have to recall what that means. That means the slope equals -2 at that particular point. Okay, so part B, f of 1. F of 1 is just the y value at when x equals 1. So that is just 2 over 1, or just 2. Okay, so now recall what's happening here. We have a curve. I don't know what it looks like, but at the point 1, now we have the y value is 2, and I guess I drew it wrong because the slope is negative, okay? The slope, if you draw a line touching at one point, the tangent line is -2. So you can now put that all together and make an equation of a line. We can use point slope form is very useful for this kind of stuff. Actually, then we're at the general equation. This is point slope form. x1, y1 stands for a point on the line, 1, 2. And m is the slope, so I'm just substitute in everything we just found. So that's y minus 2 equals the slope times x minus 1. Okay, and the question does not imply you need to write it in slope-intercept form, so we can just leave it like that.